Yeah, dear students, I have received this question from one of your friends, and I think the question is to solve the circuit for current I or current through the 10 ohm resistance using Norton's theorem, right? Right? It's always a bit tricky to use Norton's theorem in these type of bridge circuits, right? Let's see how we can solve the question for the question using Norton's theorem, right? First of all, we know the Norton's equation circuit, Norton's equivalent circuit, right? So any linear network can be simplified with a single current source of IN and the resistance of Tx or the Thevenin's resistance, right? So if you want to estimate or if you want to calculate the current I through the 10 ohm resistance, just consider this as A and this as point B, right? First of all, we need to find out the current IN, the Norton's current IN. So what we have to do is we have to short circuit the 10 ohm resistance, and the current through the short circuited part will be your IN, right? Let's see how we can calculate the current through the short circuited AB, right? So if we short circuited AB, I can redraw the circuit something like this, right? Right? So here we have a 9.8 voltage battery. For simplification, I'll mark this as 0 voltage and this as 9.8 voltage. Right? Or else I can do the same like this. Right? 9.8 voltage. Right? So this is 8, 12 ohm, 10 ohm, and 10 ohm, and this is short circuited, and we need the current IN. Right now, we can see that 8 and 12 are parallel, and then in the middle, they have been short circuited, right? You can imagine that this wire is merged together or welded together, right? So you have 8, 12, and these 10 and 10 are in parallel, right? So further simplifying the circuit, what we can do is, yeah, so we can do it as 8 parallel 12, and then we have 10 parallel 10 connected to the 9.8 voltage battery, right? So 8 parallel 12 will be 8 into 12 also, right? So 8 parallel 12, you can simply get 8 into 12 over 8 plus 12, sorry, which is 20, right? So 96 over 20 will be 4.8. Yes, and then 10 parallel 10 will be 5, right? This is 10. So 5 and 4.8. So altogether you will have 9.8 ohms as the resultant resistance. So the net current from the circuit is actually 9.8 and 9.8 ohm. Hence, we'll have, sorry, I as 1 ampere, right? Which means we are going to have the current of 1 ampere here, right? And if the current through the path is 1 ampere, the voltage at this point, right? Let the voltage at this point is 0 voltage, and the voltage at this point will be 9.8, right? 9.8 voltage. Hence, the voltage at this point will be simply 1 amps and 5 ohms, so will be plus 5 voltage, right? So if we substitute that one, so the voltage at this line is actually 5 voltage, right? Now, so if this is 0, this is 5, and this will be 9.8, right? So we need to calculate the current IN, right? The way to calculate the current is actually, yeah, the point voltage at this point is 9.8 voltage, and the voltage at this point is 5 volt, right? Hence, the voltage across the 8 ohm resistance is 9.8 minus 5, which is 4.8. Let this be I1, and I1 equals 4.8 over 8 amperes, right? So 4.8 over 8 will be 0.6 amperes. Right, again, the voltage at this point is 5 voltage and this point is 0. Hence, the voltage across the 10 ohm resistance will be 5 voltages, and let the current through the 10 ohm resistance is I2. Hence, I2 equals 5 over 10, which is 0.5 amperes, right? So now you know that here you have 0.6 amperes current through the 8 ohm resistance, and at this node you have 0.5 amperes through the 10 ohm resistance, right? So based on Kirchhoff's current law, the remaining 0.1 ampere should flow through this way. Hence, your I n can be written as, right, so 0.1 ampere or 100 milliamperes. Right, now you need to calculate the Thevenin's resistance RTH for the given circuit. Okay, how to do the Thevenin's resistance? As you know, you have to short circuit any voltage sources or open circuit the current sources. Then you should open circuit the 10 ohm resistance, right? So if I draw the circuit diagram, now I may have something like this, right? So I'll redraw the circuit. Let this be point A, this be point B, right? And then these two has to be short circuited. Right? On the other words, what I can do is I can simply short circuit these two to the middle. Right now, this is 8, 12, 10, and 10 ohms. Right? So if I have calculated the resistance across A and B, so these 2 points are short circuited together. Hence 8 parallel 10 plus 12 parallel 10. Right, so I can rewrite this as 8 parallel 10 will be 10 into 8 over 18 plus 12 parallel 10 will be 12 into 10 over 22, right? So 80 over 18, which will be 40 over 9 plus 120 over 22, which will be 60 over 11, right? So in other words, I can write it as 11, 5, 12 into 5, 16, 9, 4, 10, 40, right? So you have 40 over 9 plus 60 over 11. Simple words, if you take 99 as LCM, then yeah, 11 into 40, 40 plus 9 into 60, 540, right? So yeah, if I add these two together, then it will be 980 over, so 980 over 99, right? So approximately, I can put this as, yeah, 10, right? approximately I can make it as 10 or maybe 9.999 or something. Right now, apply your RTH as 10 ohm and IN as 100 milliamps, right? So 10 ohm and 100 milliamps in this circuit. So this will be 100 milliamps and RTH equals 10 ohm, and this will be your point A and point B. Right? The resistance connected across A and B is again another 10 ohm, right? Which means this 100 milliamps current will be divided equally among these two branches, right? So maybe you will have 50 milliamperes through the resistance and 50 milliamperes through the Thevenin's resistance. Oh, now you can say that the current to the 10 ohm resistance I equals 50 milliamperes, right? So which indicates, right? Yeah, it's a simple one, but there is a small trick into calculating the current through the short circuited line, right? So if you just practice this question, right? As I said earlier, take a piece of paper and pen, and you just write what I have did here, or you can reconstruct what we have done in the video, right? That's a easy way to learn. Thank you. If you have any other questions, please post it to me.